Hey guys, welcome back. We're day 54 here. Today we're really going to focus in on the fundamental theorem of calculus and graphs and the connection between these two. This is one of the most heavily tested on concepts on the AP calculus test, especially on the free response section. So we looked a little bit at that today in class, and I just want to do kind of a deep dive into this. Conceptually, we have to be very, very careful and know what's going on with this setup, because it's kind of the most common setup that we see in on AP AP free response. So let's take a look. I want you to take a look at this screen here. And what I want you to do is copy down this graph into your notes. I want you to title it graph of f. And then I want you to write that equation, g of x equals the integral from 0 to x of f of t dt. So go ahead and pause the video right there for a second and get this copied down. Try and be as accurate as you can on that graph. Okay, so when we take a look at this setup here, it's really important to do a couple of things. Number one, we've got two different functions going on here. We have a function f, and we have a function g. Now, the graph, it says, is listed as the graph of f. But when we take a look, right, they could ask us questions about f or questions about g. And what we have to know here is the relationship between f and g. So, taking a look here, I have a function that says g of x equals the integral from 0 to x of f of t dt. Right? That's our equation that's written up here. So they're going to ask questions then about, they could ask questions about f, they could ask questions about g. Most likely they're going to ask questions about g. So what I have to do is figure out the relationship between g and f. So what I know is doing the antiderivative of f, right, doing the integral of f gives me g. What I want to do in this scenario right here is I want to think about the function f by itself, right, without that integral sign. Well, if I want to get rid of the integral sign, all I have to do is do a derivative, right? That's the fundamental theorem of calculus. That was from yesterday's video. So when we take a look at this right away, and when you do this on your AP exam, you need to write this in the scoring region. And what we need to show here is what happens when we do g prime of x. Well, again, the fundamental theorem of calculus, which is a very simple theorem, just says the derivative of the integral of f of t dt is going to equal f of x. So when I do the derivative of g here, g prime of x equals f of x. Now, a couple of things to be careful of. I can just make that easy equation because I have an x that's on top of this integral sign, and it's a 1x to the first power. Right? If that was a 2x up there or something, then I'd have to use the chain rule, and I would say g prime of x would be f of 2x times 2, right? And that's going to change the whole scenario here. So what I have is this very, very powerful equation that says g prime of x equals f of x. Okay? That I know to be true. So the key here is go back to how I labeled the graph. I labeled it as a graph of f. But that is not only what the graph is a graph of. It's not only a graph of f, but since f equals g prime, this is also a graph of g prime. super, super, super important to realize that that is a graph of G prime. because what they can ask a whole multitude of questions. We'll take a look at them in class tomorrow, the different types of questions they can ask here. But if they ask you a question about G, understand the graph we're seeing is not a graph of G, but a graph of G prime. We have to keep our G's and F's. We have to keep them straight. We have to keep our G's and G primes straight. Okay, and I can ask all kinds of questions about G or F or G prime or F prime. I can ask any of those questions, and we have to be ready. I don't know what they're going to actually ask on the exam, but we have to be prepared for any and all of those questions. So if you see this setup, okay, which you almost certainly will at some point in time on the test, if you see this setup, the first thing you want to do is do the derivative of G and show that G prime of X equals F of X. And then go ahead and label your graph as also the graph of G prime. Okay? And I'll show you how confusing it can be with the types of questions they ask. Okay? So here's question 1 that might be asked. Okay. So I might ask a question like, find G of 4. Okay, well, is my graph going to help me? Well, my graph is of G prime, so I can't just read the, look for an X value of 4 and figure out what the Y value is. It's not that kind of problem. To find G of 4, I need to look through here and see, where do I have something in terms of G? Right, I've got a graph of F, I've got a graph of G prime, and I got an equation for G prime. But the only place I see G is right here. G of X equals the integral from 0 to X of F of t dt. So again, this is my initial connection between G and F. To find G of 4 then, I just want to use this equation and plug in 4 for X. So setting that up, when we evaluate a function at a value of 4, right, I just look at G of X and replace all the X's with 4's. So G of 4 by definition has to be the integral from 0 to 4 of F of t dt. So now I get my connection to F. This is a graph of F. So to do the integral from 0 to 4, I'm simply going to find the area under the curve here from an X value of 0, 1, 2, 3, 4 is that 0 to 4. So I just want to find the area of that shape, which is a triangle. So the area of a triangle is base times height divided by 2. But I also need to be careful and think about this as a whether or not it's going to be a positive or a negative number. Right? I see that triangle sits above the x-axis, right? We're up here above the x-axis, so it's going to count as positive. I know G of 4 is simply going to be the area of this triangle, right? I see it's got a base of 4, a height of 2. 4 times 2 is 8. 8 divided by 2 is 4. So I get G of 4 equals 4. Now, let's say I said something like, find G of -2. Well, again, I'm looking for a question about G. My graph is of F. My graph is of G prime. The only thing I have with G is G of X's equation. So again, I'm going to use the same thing. I'm going to do the integral from 0 to -2 of F of t dt. Now, the first thing that you need to see here is that when we write this, I'm doing an integral from a higher number to a lower number, right? The bottom number now is a bigger number than the top number. So I got to be careful with that. The first thing I want to do here is flip these two. And when I flip them, I have to do what? Well, I have to throw a negative out in front. Okay. Again, I don't want to forget about this negative out front here, okay? And when I look from -2 to 0, right, I see a shape that's above the x-axis. That shape is a trapezoid. Okay, but I'm going to change it into a square and a triangle. The square is 2 by 2. So that gives me a value of 4. So that area there would be 4. The triangle is a 2 by 1. 2 times 1 is 2, divided by 2 is 1. So I get a total area of 5. And that reports as positive 5. But because of this negative that I have out front, I have a -1 times 5 to get an answer of -5. Okay. So that's how we can answer questions about G. Okay. Next question we might see is something like this. Now again, what's different here is now I ask you to find G prime of 0. G prime of 0. So I'm not going to be doing my area under the curve like I did for just regular G, right? Again, it's not a question about F. It is a question about G prime. So when I go back and look, this is why we make this note. This is also a graph of G prime. So to find G prime of 0, right? When x is 0, G prime is equal to 2. Right? I just read the y value there of 2. Okay, so I'll go ahead and put that in there. G prime of 0 equals 2. Okay. Now, what if I had a question of find G prime of 6? Well, taking a look at my graph here, right, this is a graph of G prime, so I'm looking for G prime of 6. I go ahead and read this, and I see G prime of 6. Here's 4, 5, 6. G prime of 6 has a y value of -1. Similarly, right, this could have also, since G prime and F are equal, if you ever want F of something, right? So let's do this over here. Find F of -2. Well, I can use the exact same method as G prime because F and G prime are equal. That's why that relationship is so important. F of -2, this is a graph of F. F of -2 is a value of +3. Okay. Now, let's check out this problem. Okay. On what value, or sorry, on what interval is G increasing? Justify. Okay, so I want to know where G is increasing. Now here's where you need to be careful. The question is about the function G. I want to know when G is increasing. Now this throws back to before Christmas, okay, and our definitions on what makes a function increase or decrease. We need to know that G increases when G prime is positive. So right away in my head, I'm thinking, G is going to increase when G prime is greater than 0. Well, how do I answer that question? Well, very simply, because I have the graph of G prime. I just want to know when is this graph, G prime, greater than 0. Well, I can see this graph is greater than 0 from -1, 2, 3, 4, 5. From -5 to 4, union, and this looks like about the half mark here, right? Union 6.5 to 8. Okay, but that's not a good enough answer because we have to justify. Okay, we justify with our definitions. Our definition is G increases when G prime is positive. But we need to show the greater that we can make the connection between the graph of F and the graph of G prime. Okay? So we need to say because that is when G prime of X equals F of X, right? Our graph is positive, is greater than 0. Okay? And instead of writing is positive, you're welcome to say is greater than 0. But you can't say it, just like before Christmas, right? Our justifications need to reference very specific things. Now, we can ask all kinds of more questions about that, right? All those questions that we had in our F prime graph unit, we can ask on this thing, right? I might ask, when is G concave up? Well, again, I'm not going to write this down, but I want you to think about it, and we'll practice it tomorrow. G is concave up when G prime is increasing. So G prime would be increasing right here to here, and from here to here. They might say, what are the critical points of G? Well, the critical points of G are when G prime equals 0 or undefined. Well, G prime is 0 right here. This would be a critical point of G. That X value, right, -5, +4, and +6.5. What kind of critical points are they? Local maxes, local mins, or neither? Well, X equals -5 is a local min because G prime switches from negative to positive, right? That's our justification. X equals 4, G has a local max because G prime switches from plus to minus. Here's another local min of G over here because G prime switches minus to plus. Right, so all those things that we reviewed back before, that we did back before Christmas, are going to come into play, could come into play again in this scenario. But again, it's all based on seeing the relationship between, that's based on the fundamental theorem of calculus. Right, so if you can't do this, if you can't say G of X, since G of X is equal to the integral from 0 to X of F of t dt, you need to see that G prime equals F. This is our gold here, because that ties this graph to G prime. Okay? Last question for you before I end this video, and we'll practice it a lot tomorrow. Question 7. Find G double prime of 0. Okay, now, when I look through this, I don't have G double prime anywhere, right? I have G, I have G, and I have G prime, but I don't have G double prime. Well, we can go right back to this and say, well, if G prime of X equals F of X, G double prime of X would equal F prime of X. So, G double prime would be the slope of my G prime graph or the slope of my F graph. So if I want G double prime of 0, I would look to my X equals 0, and I'd want to report the slope of this line. Well, I can tell that this slope is negative. It goes down 1 over 2, down 1 over 2. So we have a slope of -1/2. So G double prime of 0 would equal -1/2. Also, on these G double prime questions, just be careful of these corner points, right? G double prime is going to be undefined at these corner points because we can't do a derivative at a corner like that. Okay, that should help get you prepped and primed for tomorrow. We'll be looking at some tough problems, okay, and it's going to test a lot of different knowledge we've gained throughout the year. I'll see you guys tomorrow. 2 chains, bye.